As you know, with fractions, right, we have other things we can do with them besides just simplify them, right? We can do all the operations, add, subtract, multiply, divide. Actually, it turns out it's easiest to begin with multiplication and division. So that's what this video is going to focus on. Next one, we'll look at addition and subtraction. Okay. When we multiply fractions, right, we know we just multiply across, yeah? So like here in this first expression where we have 2/9 times 3/4, we would just multiply across. So it'd be 6 over 36. And then we would go ahead and simplify. So we know 6 goes into, so for every 6, we go into 36 6 times. So then that is just 1 over 6. Okay. Also, similarly, you could have canceled at the beginning and said, okay, the 2 goes into 4. I'll just show you what that looks like. 2 goes into 4 twice, and 3 goes into 9 3 times. And that should be a 3. Okay, and then you can just multiply across, right? We just multiply numerators, multiply denominators. Simplifying can occur before you do that or after, either one. Okay, so let's do the same thing here. So again, if I were to multiply straight across, I can do that. I'm actually going to be a little wiser. Well, let's just do it because we'll stick with the same principle. Okay, so 5 and then x squared, or 5x. 5x and then x squared minus 4 over 10x and then x squared plus 5x plus 6. And I'm kind of done, but I should factor first fully from here. So factor fully, and I go 5x. This would be x minus 2, x plus 2, difference of squares, right? And then 10x, and then this would be x plus 3, x plus 2. Okay, and now, right, I can cancel common factors, and I'm going to just say pause, right? We should always note our undefined values. So this gives us 0, so x can't be 0, x can't be -3, and x can't be -2. Okay, you might need to set each one of these factors from the denominator equal to 0 to see that, and solve. That was from the previous video, so I'm just going to kind of skip that skill. Now that I have this all factored, I can reduce. X plus 2's are common, those can cancel. There's an x, those can cancel, those can reduce. 5, for every 1 5, that goes into 10 twice, and now I think I'm ready just to clean this up. So just clean up numerators, clean up denominators. So I'd have x minus 2 left in the numerator, and 2 times x plus 3 left in the denominator. And if you want to distribute the 2, you're welcome to do so. All right? So multiplication, same as fractions. Okay, just with variables in there. Division, same principle as with fractions. Just a reminder of how to do that. So you might have heard this phrase of keep, change, flip. Okay, and so that's sort of the short process that I keep in mind when I'm doing these things. So I would keep the first fraction alone, change the sign from division to multiplication, and then flip the second fraction. Okay, change it to its reciprocal. And again, multiply across, so 20 over 35, and then that can reduce, right? I think there's, if I divide this by 5, I'd get a 4, and divide that by 5, I get a 7. So then this is all equal to 4 over 7. Okay, and certainly you could have reduced back here and said, okay, that goes in there once, that goes in there twice, and you get the 4 over 7 like that. Okay, do the same thing with fractions now. Okay, this looks very scary, but it's not that bad. Y squared minus 36 over 2y squared plus 11, y minus 6 times, okay, times the reciprocal 8y minus 4 over 2y squared minus 2y minus 60, okay? And so, again, multiply across y squared minus 36, parentheses around that, 8y minus 4 in parentheses, 2y plus 11y minus, or 2y squared, I'm sorry, 2y squared plus 11y minus 6, and then 2y squared minus 2y minus 60, okay? And now all I have to do is reduce, simplify this thing. So I need to factor, yes. Okay, and I like factoring. I'm going to come down here. Okay, that first piece is going to be y minus 6, y plus 6. Okay, second piece, I pull out a 4 and I end up with 2y minus 1. Okay, this is all multiplied together. Denominator, this next thing factors as 2y minus 1, y plus 6, and you're welcome to verify that. That'd be 12y, or 12y minus y gives me, or 12y minus y gives me 11y. And then the next piece, if I take out a 2, I'm just going to do this here. I have y squared minus y minus 30. Okay, well that means that would factor as y minus 6, and then y plus 5. Yeah, okay. And you're welcome to verify that as well. Now I can cancel common factors, right? There's a y minus 6, I can see that one. 2y minus 1 pops out. Oh my gosh, we have so much canceling. Y plus 6 cancels. What is left? Oh, the 4s and the 2s. Those cancel too, so I get a 2 there and a 1 there. Okay, so I did all that work and it just simplifies to 2 over y plus 5. Isn't that much easier to write? Okay, now that's the final answer for this one. Again, you're welcome to do this factoring. Oh, and I skipped a step. I got to go back and undo that skipping step. Now, in terms of simplifying, right, you're welcome to do that before you actually do the operation, just so you don't have to write as much, yeah? Kind of like we did over here in green. You're welcome to do that if you want, but again, you sort of need to factor it first. Okay, now the step that I skipped was before I canceled, I should note the undefined values. So from here, y can't be negative, actually just positive 1/2. From here, I can't have y equal negative 6. Here I can't have y being positive 6. And then this last one would be negative 5. Okay, so I should just note those in the event of, that the world blows up. I just need to know that those are undefined values. Or rather, when we get to equations, we just need to be able to look back and say, okay, is the value I find an undefined value or not? And so be aware of that. To summarize though, working with rational expressions that are being multiplied or divided, same as working with fractions, just multiplication, multiply cross, denominators, keep, change, flip.